If you recall, yesterday I mentioned that we are in final exam season. And we talked about a solid surface and curve yesterday that we could use for problems. We wanted to think about how that solid surface and the curve could show up in various problems that we might want to write. So in addition to that, since one of the things that we've been talking about is vector calculus, we need to look at these couple of vector fields. And I posed the question, which do you prefer? Which vector field would you more like to work with? And why would you make that choice? Clearly, the second part of the question is the only part that matters. Why we would choose one vector field over another. All right. So if we think in terms of the fundamental theorems of calculus, let's just write down our fundamental theorems of calculus. We have the integral over some curve of the gradient of a function dot dr is f at q minus f at p. We had the integral over some surface of the curl of a vector field dot dA is the integral of the vector field itself around the boundary of the surface. Now the integral of some solid over some solid of the divergence of a vector field dV at each point is the surface integral of the vector field dot dA. There's a lot that goes into these. We do have to specify that C is some path starting at P and ending at Q. We have to specify that for Stokes' theorem, C is the boundary of the surface S. We have to know that dr is a vector in the direction of the curve C at every point. dA is a vector normal to the surface at each point. And then for the divergence theorem, we need to know that S is the surface of the solid W. So what we notice is that is in our fundamental theorem of calculus, we have the integral over some curve of a gradient field dot dr means we can just evaluate the potential function at the endpoints. And so when we look at our vector fields f and g, the first thing that we want to consider is this vector field a gradient field? Because if this vector field is a gradient field, then our life is going to be much easier in terms of calculations. If we know that this vector field G is a gradient field, then calculating a line integral is going to be very simple. We just need to find the potential function and then evaluate that potential function at the endpoints. But then we think about the situation where we might place this vector field. Considering the surface yesterday had a boundary that was a closed surface, a closed curve, P and Q are the same points. So if I wanted to integrate a gradient field around that curve, we know we're going to come up with 0, and we don't have to do any calculation at all. We just have to know if we're dealing with a gradient field. I guess we'll have to do some calculation, because we'll have to decide if it's a gradient field. So that's the way we want to decide on which one we would prefer. Now, from a practical standpoint, I'm probably going to give you both, give you problems involving both, one that's a gradient field and one that's not a gradient field. But I want to make sure that we know that life is much simpler if we're integrating a gradient field, because we're integrating something that I'm telling you is a derivative. Any questions? The other reason that I want to point this out, that I specifically pick these two vector fields and point this out, say, oh, hey, check for gradient fields, is that when I don't do that, everybody just does the calculation. Everybody just like, no one checks to see if it's a gradient field. You just do the calculation. And it's kind of an impressive amount of calculation. But it's an impressive amount of calculation that didn't need to happen in the first place. Does that make sense? We kind of overcomplicate things. The algebraic equivalent of this warning is when I ask algebra students to add a couple of polynomials, and they're quadratic polynomials. And on the same test or quiz, they're also multiplying polynomials. And so students will start multiplying the two quadratic polynomials. Ignore the big old plus sign in the middle and start multiplying, which, if you recall, 3 terms times 3 terms is going to produce a lot of terms. So now when I do that, I hand them the paper and say, note that this first one is addition, not multiplication. Then if they still multiply, I'm like, well, that just means they don't understand the difference between addition and multiplication. Any questions? How's everybody? Everybody looks so sad today. Is it because finals are happening? Is it stressful? With finals in mind, let's be very clear about how procedures are going to work. Final exam, spelled final wrong. The final exam problems will show up in the quiz module on Canvas. So to clarify, we will not have an in-person final exam. On these problems, this includes the ones that I've recently posted. For these problems, the usual rules apply. There's no time limit except for the deadline, and you get unlimited attempts. There's no time limit on the problems, but there is a limited amount of time to complete the problems. So I don't start a timer when you start doing the problems, but there is technically a time limit on the problems because all the problems must be completed by Friday, December 16th at 11:59 p.m. All the final exam problems must be completed by Friday, December 16th at 11:59 p.m. Any problems left incomplete will receive a score of 0. Incomplete problems with a score of 0. Some of the problems are graded by Canvas. So I've set some of the problems up to be graded automatically by Canvas. So you'll know right away whether the problem was correct or incorrect. If you believe that your problem was scored incorrect because of a syntax error, that is, you're not typing it incorrectly and you want to check, you need to let me know. The worst message that I get is a student saying, I spent 3 hours trying to plug this in and it keeps coming back incorrect. Then I look at the responses and they plugged in the same thing like 1,000 times. I'm like, oh, dude, it's a computer. It's not, you're not going to convince it by like asking it the same thing a bunch of times. Do you know what I mean? At a certain point, you need to stop and say, oh, is there some, maybe I'm the problem? And then message me, say, Leach, I think I have the right answer. Am I just communicating with the computer? Always blame the computer, right? The controller is broken. That's why you're winning. Or I get a message from a student that's like, well, I've been spending 3 hours on this one problem. And I'm like, well, that's the problem right there. You just skipped going to the gym for a week and then tried to make up for it by going to the gym and lifting for 8 hours on Saturday. Oh, what are you working on today? Today is leg day and chest day and arm day. And it's just, that's just not how shit works. You gotta stop. Some problems will be graded automatically by Canvas, and so you'll know right away. Some problems will have to be graded by me, and so you'll have to wait. I'm going to go through multiple rounds of grading before Thursday, December 15th. I will be going through multiple rounds of grading before Thursday, December 15th. Thursday, December 15th will be my last review day before I'm only going to be looking at final submissions. So if you submit something on Friday, it's not going to get reviewed. That's going to be your final submission. But if you submit stuff before that, I will go through it and try to give you at least one chance to review each problem. Any questions? If you just wait till Friday, you're just saying, I can do this all at once, and I don't want review, which is fine. That's your choice. I think it's a bad idea. There's a reason that I'm not holding this final in 2.5 hours and giving you instead 2.5 weeks. Any questions on procedures? I will let you know when I'm done writing problems. There will be an announcement when the last problem is posted. So I'm not sure which problems are making the final cuts. I'm going through cuts right now. I don't want to just give you all the problems because there's too many of them. So I have to decide which ones are my favorites and then cut the rest. The homework assignments will be cut off earlier than the final exam problems. All homework assignments must be completed by Friday, December 9th at 11:59. These are all dates of this year. Incomplete homework assignments will get a score of 0. The homework assignments are anything that's in one of the chapter modules. The final exam problems are anything that's in the quiz module. Anything in the quiz module, you have until December 16th. Anything in one of the chapter modules, you have until December 9th. If you have not completed some of those assignments, it's still possible to have 100% in this class because I haven't gone in and zeroed out the assignments. The scores don't zero out automatically. You do not get to express surprise at the sudden nosedive your grade takes when you go from 100% to 20%. If you know that you haven't done any of the homework assignments. Any questions? It sounds crazy that I have to say that, but I have to say that. I get emails all the time from students who know that they haven't done any homework, wondering why their grade is so low. Canvas doesn't automatically change incomplete assignments to 0 because I keep them available until December 9th. So on December 10th, if you wake up and say, well, wow, this class was easy, there was no homework. Then you check on Canvas and you've got 20% in the class. That's why. So don't all email me and express surprise. And, oh, can I do the homework now? I have a whole week. Because I'll be like, oh, motherfucker, I gave you 17 weeks to do these assignments. You ain't going to finish them in a week. And they're like, well, yeah, I could finish them in a week. Nah, you ain't going to finish them in a week. Because I'd have to let you do that, and I'm not gonna. See how it works? Any questions? All right. So this is how we're going to deal with tests and quizzes and final exams. We're just gonna put all that shit online and let you work at it from there. Now, if you're wondering, but if we're entering the problems, don't we have access to Google? And I'm like, oh, yeah. You also have access to each other. So, I mean, isn't that the point of this? To learn shit? If you take that opportunity to not learn stuff, I mean, you're going through a lot of effort to not learn stuff. Most of the time, I watch students as they cheat and try to commit fraud upon their instructors. And I'm like, oh, dude, it would just be easier to learn shit. So I'm just going to try to set up a system where that's encouraged. Now, I realize most of you have been trained to not learn stuff and just score points. I don't blame addicts for their addiction. We raised you to be this way. We raised you to chase points. What can I say? I read building 4, or is it building 5? Can't remember which building it's on. And I guess I just want to be the change that I want to see in the world. And I say, I'm going to work from the assumption that y'all are here because you want to learn about calculus. And I'm just going to encourage that and not try to police your behavior. I'm not a cop. It's not what I signed up for, so I ain't going to do it. Any questions? I've disabled comments on all my YouTube videos, so all of you that want to comment on it, you'll just have to scream into the void. Any questions? Comments? Snide remarks? Deep thoughts? Now, you can think that I'm wrong for being this way. This is an experiment that I'm trying. This is a conclusion that I've come to. I've only been thinking about this for 30 years. So, I mean, heck, maybe I'm wrong. This occupies a weird space. And there's a lot of things that you have to resolve the more that you know. I think I've mentioned before, by the time you graduate, you should graduate from college with way more questions than you had when you matriculated college. You got to try to figure out how all this stuff works together. So, at the very least, all I can say in my defense is that I don't know if I'm right, but I know what I want education to look like, and so I'm just gonna fucking do that. You know what I mean? So maybe next semester or the semester after that, I'm just going, nope, in-person final, 2.5 hours, and it's going to be impossible, except for like the 3 students who don't need the grades anyway. Everybody else will be asking for extra credit. And maybe I'll just backslide on that too. I don't get the extra credit thing. I don't know where this came from. Extra credit is like more difficult than the regular credit. Students ask for extra credit when they're really asking, can I get another chance at the regular credit? So for the rest of the semester, rather than having in-person meetings, I'm going to be doing just Zoom meetings. I'm just going to be sitting up in my office. I'm going to open up Zoom, and it's only going to be open for questions. If no one has questions, then I'll probably just be sitting on Zoom all by myself. So for the rest of the semester, So the remainder of the meetings will just be held via Zoom and used for questions. There's not going to be any new material. We have enough. I think from a student standpoint, I left out a word. We have had enough. I should put a had in there, but it makes it a little more forceful than I think it needs to be. Any questions? Comments? If you don't have questions, you could always just feel free to sleep in. I won't be recording these because I'm just going to be answering people's questions. That way, you don't have to feel uncomfortable like your voice is going to be recorded and put on YouTube's. And then people will make fun of you. Because internet. Any questions, comments, snide remarks? All right. All that we have left is a bunch of problems that we're going to call the final exam. This is starting tomorrow. Starting tomorrow, all the meetings the remainder of meetings starting tomorrow will be via Zoom only. I'll just be sitting up in my office. So if you happen to be on campus and you want to talk to me in person, you just go to my office. My favorite thing was I was doing this one semester. Doing this last semester, I was sitting in my office, just kind of running a Zoom session online. And someone was sitting outside my office on their computer in the Zoom. And I like opened the door, like, wait, what would you? It's like, well, I didn't want to knock on the door. Like, all right, fair. I don't like knocking on doors either. Right? So maybe the door is closed for a reason. Well, I thought that was kind of funny. All right, that's going to do it for today. That's going to do it for the in-person portion of this week. That's going to do it for the in-person portion for this semester. I appreciate you all coming in and giving me your attention, especially on days when I don't have a lot going on mathematically. So thank you for playing the Calculus 3 game with me. Good luck on the rest of the problems. Everybody have a good break if I don't talk to you before then.